Okay, so today we're going to learn how to complete the square, which is a technique that will help us not only in factoring quadratic equations, but also in deriving the quadratic formula. So let's take a look at something first that we need to review, which are perfect squared trinomials. So perfect square trinomials. Okay. Perfect square trinomials, right, are what we get when we square a binomial, a two-term thing. So if we have x plus 3, and we square that, we get x plus 3 times x plus 3, and we square it, or we multiply the first two terms, we get x squared, multiply the 3 and the 3, and we get 9 at the end. And then in the middle, we're going to get 3x and 3x, so a total of 6x. If we do this without numbers at all, just with variables here, we did, for example, m plus n, and we square that, that gives us m plus n times m plus n, which gives me m squared at the beginning, n squared at the end, and we're going to get mn twice, so we get 2mn. This form is a perfect square trinomial. Whenever we see this, we have a perfect square at the beginning, a perfect square at the end, and 2 times the two terms multiplied, 2 times the product of those two terms. Right? We know this is a perfect square trinomial. So we're going to use this idea to actually factor into a perfect square. So let's look at an example here of something that's not a perfect square, but can become one pretty easily. So let's say we had y equals x squared plus 6x plus 7. Now, if this were a perfect square, that 7 would, of course, be 9, just like we just saw. Right? In this case, how do we get from 7 to 9? Well, we can add 2, and we have to add 2 to the other side to balance it. So we get y plus 2 equals x squared plus 6x plus 9. Of course, we know that x squared plus 6x plus 9 is really x plus 3 squared. And then we can just subtract the 2 from both sides and rewrite this equation as y equals x plus 3 squared minus 2. So that's another way to write the same equation. One of the things we're often going to do, right, is set y equals to 0. And then we're going to go ahead and solve, right, for x. So it's 2 equals x plus 3 squared. And then we can do square root of both sides. Square root of 2 equals x plus 3, which gives us altogether the square root of 2 minus 3 equals x. So our final answer here, if we wanted to solve for x, which is an irrational number, we don't necessarily need to solve for this in this case, but it would be square root of 2 minus 3, or negative 3 plus the square root of 2 if you want to write it that way. Okay, so what we need to look at here is some more examples of completing the square. So this process that we went through here of turning this into this is called completing the square because we're making it into a perfect square. Let's look at another example here that's a little trickier. If we have y equals 2x squared plus 12x plus 7 again, the heck. So a little different here because we have a 2 in front, right? And that's going to change things. First of all, let's say we're solving for x when y is equal to 0. That makes things a little easier here. So we get 2x squared plus 12x plus 7. The first thing we have to do here is factor the 2. We have to divide everything by 2. So it's x squared plus 6x. And you'll notice at the end here we have 7 divided by 2, which is a fraction, but that's okay. Right? It's 7 halves or 3.5. However you want to think of it. I prefer the fraction, you probably don't. The next step is to divide both sides by 2, get rid of that 2, and since we're dividing by 0, or dividing 0 by 2, we get 0 again. So we have x squared plus 6x plus 7 halves. Now, just like last time, we have to figure out what's going to give us our perfect square. In this case, our perfect square is going to be x squared plus 6x plus 9 again, right? But we have to figure out what do we add to 9 to get 7, or sorry, what do we add to 7 halves to get 9? We want to get 18 halves, so we need to add 11 halves, which is 5.5 added to 3.5, also 9. We got to add the same thing here. So we get 11 halves equals x squared plus 6x plus 9. So 11 halves equals x plus 3 squared. Now, if we wanted to solve this, we would just square root both sides and subtract 3. It's a crazy irrational number. I don't really care what it is. But we can do that very easily. Square root and subtract. Let's look at another example here where we have another leading coefficient that's not 1. So let's say we had y equals 2x squared plus 3x plus 4. Once again, we have to factor, right, that 2. So, and we'll set this equal to 0 again. It makes things a little easier to work. This time we have a 3 that we're dividing by 2. So we have 3 halves in the middle. And then we have 3 halves in the middle of this equation, which makes things a little tricky when we're trying to find that last term to make this perfect square. What we can do, again, is divide by 2. We know, right, that 3 halves, we know that the last term here is going to be half of 3 halves squared. So 3 halves times 1 half is 3/4. And then we're going to take that to get our last term, we're going to take that and square it, which gives us 9/16. So here we have to go from 2 to 9/16. This is a little tricky because of the fractions, but it's not any better with decimals. So 0 equals x squared plus 3 halves x. We want to have 9/16. So right now we have 2, which is, of course, 32/16. So what we actually need to do here is subtract from 32/16. We need to subtract 23/16. And for the other side, okay, so here we have our equation. We have negative 23/16 equals this whole business, x squared plus 3 halves x plus 9/16. And that's our perfect square trinomial. It doesn't necessarily look like a perfect square trinomial, but it is. We went through and figured it out. So that's going to give us at the end here negative 23/16 equals x plus 3/4 squared. Interesting to note here, if I took the square root of both sides, I would end up with an imaginary number. What that means is that this actually is never equal to 0. We'll talk about that in just a few minutes. So again, when we go through to complete the square, we have to factor out any leading term, right? Then we figure out what half of the middle term is, right? And then we make the last term that number by adding what we need to both sides, adding or subtracting. So, okay, so let's watch the next video, and I'll show you how to do this with the quadratic formula.